YouTube channel. In this tutorial, I am going to discuss the probability distribution. So what is the probability distribution? We all know that what is the distribution and probability distribution. But now, today I'm going to discuss the one more important distribution. That distribution is called Poisson distribution. So there are lots of case study where we have applied the Poisson distribution. But now question is that where you apply the Poisson distribution, that is the more important thing. So I am going to give one more examples that help to understand the complete concept of Poisson distribution. So let's start. So like there is the example first. A city where 10 children's 10 baby born in every hour. So what is the probability? What is the probability of 10 baby, yeah, or 20 baby born in next hour? How to identify this question is the based on Poisson distribution or not? First, try to understand a city where 10 baby born in every hour. So what is the rate or interval of baby born in hour? So simply you say rate is 10 baby per hour. 10 baby per hour. So this kind of value give the support the Poisson distribution concept. So now try to understand the Poisson distribution. So any activity that is the time bounded or space bounded, such kind of problem is solved by the Poisson distribution. That is the concept of Poisson distribution. So now come to the next part of I give the one more example for the more understanding. A store where 100 customer arrive every day. So what is the probability of 1500 customer arrive next day, or 50 customer, 500 customer in next hour. So just apply the concept. So what is the interval? What is the time bound here? So rate is 100 customer per day. 100 customer per day. So that is the rate. So easily identify the rate. So now you can able to apply the Poisson distribution. But how? Okay. So there is some condition. So what is the condition? Condition is that but R is always denoted by lambda. Okay. So what is the lambda? Right? Expected number of event per interval. Okay, so that is called lambda. So value of lambda depend on the how to define the interval. Interval may be day, minute, hour. Okay, so just that is the concept of Poisson distribution. But there is some condition. There is some rule. So how rule is the how to decide the Poisson distribution. Okay. So first counting. Okay. The experiment. The experiment count the number of occurrence of an event over an interval. Okay. And now first independence. The occurrence of independent. The occurrence of one event does not affect the another event. So these are the condition of Poisson distribution. Another effect, sorry, another event does not affect the another event. Okay. So you understand the what is the rate, what is the counting concept, what is the independence, and now no two event occur simultaneously. That is the more important thing. No two event occur simultaneously. That is the concept of Poisson distributions. Okay, so I think all are clear with the concept of what is the Poisson distribution, where you apply. So for the Poisson distribution. Okay, and now come to the example, and also I derived the concept of formula. Question is, this is the interview questions. NH 65, so national highway, 5 accident, national highway 65, this is the highway name. 5 accident occur in a day. It's an average. Okay. So 5 accident occur in a day on the basis of average. Okay. So now question is what is the probability? What is the probability of 10 accident occur in next day? Next. So how to solve it? So first, what is the lambda here? Yeah. Okay. So lambda is 5. So what is the k here? X is equal to 10. That is the probability of 10. So how to establish the formula here? Formula is p x to power 10. X is equal to 10. So 5 to power 10 e to power minus 5 divided 10 factorial give the probability of 10 give the probability of 10 accident occur in the next day. That is the concept of, that is the Poisson distribution. So just understand the formula. Formula is P is equal to X is equal to K. K means this 10 accident, and lambda, that is the rate, and K e to power minus again lambda divided K factorial. So clear? That is the concept of Poisson distribution. So using the Python, mu is equal to 5, and you can easily calculate the distribution. Clear? Apply the same question to calculate the distribution. So from scipy dot stats import Poisson. Poisson when. Okay. So now Poisson dot PMF. So what is the K here? K is the 10. And mu is equal to 5. Rate. Sorry. Mu is equal to 5. So probability is the 17%. There is a probability that maybe tomorrow 10 accident happen. 17%. 1/7. So there is a very less probability. There is a very less chances. Clear? Now, just for more understanding, I give you